Hi, this is Mr. Max. This is the paper 2 that was written by the grade 11s in 2020. It's based on the Namibian ordinary level certificate. So learners who are currently in grade 10 can also go through this material. I am also going to upload the question paper. You can get it from your schools, but I'm going to upload it onto the Google Classroom. Right, so let's start right away. The paper, as I said, was 3 hours long, 120 marks. So you need to make sure that you do the best that you can. So here you have a list of numbers, and you are only supposed to use these numbers here to answer the following question. So square number from this group of numbers, the square number here is 36, which is the square of 6. A prime number, remember, is a number only with one factor, or two factors rather. It's the number itself on 1, and the only prime number here that satisfies that is 2. Negative 3 is not. Prime numbers are positive numbers, and also these are directed numbers on this side, the negative 3 and the fraction. So prime number is a whole number that consists of two factors only. And the first prime number, the only prime number, the set of prime numbers that is even is 2. Cube number, 8. 8 is a cube number, that is a cube of 2. 2 times 2 times 2. A negative integer is a positive or negative whole number, including 0, but a negative integer will therefore be negative 3. Not negative 2 over 3, because that is a fraction. A number that is equal to negative 0.6 recurring, that dot means it recurs, is the same as negative 2 over 3. Okay, so 1 mark for that. It's warm-up questions. It's right in the beginning. Right, question 2, you're supposed to work out 40 divided by 160,000. So whatever you do, you can change the settings on your calculator, or you can simply divide and then you change it, but your answer should be 2.5 times 10 to the negative 4 power. Then you have got the inequality signs that you need to insert to make the statements true. So you have to put greater than, less than, or you have to put equal. Alright, so 5 to the 4th power, well, you work that out on your calculator or so, you realize it's 625, whereas 4 raised to the power of 5 is equal to 1024. Quite clearly, 4 to the power of 5 is bigger than 5 to the power of 4. So therefore, we will say that 5 to the power of 4 is less than 4 to the power of 5. And then perhaps you can also use your calculator. So when you do this on your calculator, remember this is square root of 25 plus 9. Okay, so in a nutshell, you have the square root of 34, which is some number 5.83095. While you have 2 over 3 all squared gives you 0.44 recurring. So quite clearly you can see that 5.8 is bigger than 0.4, and so on. Now when you are doing part C, now remember you have a number line, so you look at the further the number is from 0, the smaller it becomes. Like if you have a number line, and I have to maybe reiterate this quite clearly, if this is a number line and our 0 is here and our negative 5 supposedly is here, and let's say negative 2 will be here. So you see, the further a number is from 0, the smaller it becomes. Alright, so using that idea, you will see that negative 3.125 is further than negative 3.1025. So this one is closer to 0 wherever it's going to be. Okay, while the other one is a bit further from 0. So therefore negative 3.125 then is smaller than negative 3.1025. So you have to look at the place value. So when you are dealing with directed numbers, think about which number is further away from 0. The further a number is from 0, the smaller it is. Okay, right. So when you do 9 times 7, well, 9 times 7 is 63. Minus 9 times 5 is 45. It's the same thing, so these two are therefore equal. Brings me to question 4, a little bit of algebra here. So you have what, 5x plus 2y plus 3x minus 4y. So what I did is I just grouped the like terms together first of all with their sign. So 5x plus 3x then 2y minus 4y. So therefore that brings me to 8x. So you only add the coefficients, the numerical coefficients, the numbers in front of the letters. You're not adding the letters. It's like 5 bicycles plus 3 bicycles gives you 8 bicycles. Okay. Well, here you have an equation. No need to multiply this out. It's already factored. So you must put x minus 3 equals to 0, or x plus 6 is equal to 0. So remember, for anything to equal to 0, when you do multiplication, it implies that one quantity should be 0 or another quantity should be 0. So in a nutshell, what number can I insert here that will make this bracket 0? Well, I should find 3, because if you solve this equation, if you put positive 3, that makes it 0. Or what number should I insert here to make this bracket 0, and it's negative 6. So therefore, you don't have to go multiply, get some quadratic equation that is not, it's already factored from. Two solutions can come by taking each bracket and letting each factor equal to 0. Right, here you have got some equation, w plus 4 over 9 equals to 7. So what you do here, it will be best if you can clear that denominator. That means you multiply throughout by 9. So that leaves you w plus 4 here, and 7 times 9 is 63. And the only thing you're supposed to subtract 4 from 63, and w is 59. You have your two simultaneous equations here. There are many ways that you can do these simultaneous equations. You can make y the subject of the formula. You can also make the coefficients equal to, maybe by doubling the second equation. Whatever method you imply or use, you will have to get to the same answer. So what I did is I multiplied the second equation, the 2x plus 3y here equals to 9. I multiply each term there by 2. So 2 times 2x is 4x. 3y times 2 is 6y, and 9 times 2 is 18. And I brought the other one down, so I now know I can simply just subtract the other equation. So it's totally up to you which method you prefer. Now the 4x, they cancel, or they eliminate. 6y minus 5y, that's 5y. 6y minus 1y, remember there's a 1 there, it's 5y. And 18 minus 13 is 5. So it's clear that y is equal to 1 when you divide. So now that you have the answer of y, put it in any one of two original equations in order for you to find the value of x. So I'm using the first one here for x plus whatever the value of y is. In this case, it's 1 equals to 13. Right, get that 13 to the other side, gives you 4x is equal to 12. 4 into 12 is 3. So the value of x is 3. And the value of y is 1. Here you're supposed to factorize completely. So the first one is very straightforward. 1 mark, 2 terms, you look for common factor. And the common factor there is just 2. Take 2 outside the bracket, then inside the bracket you have 2m plus n. So the way you check whether you're on the right path or your answer is correct, simply go multiply back and expand back and see if you get to this expression here. So 2 times 2m is 4m, and 2 times n is 2n. So hence you have factorized this expression correctly. Here you have got 4 terms, and the way you deal with 4 terms, they are not quadratic. The way you deal with 4 terms, you also either have to look for common factors or you have to group. So you can group, and what I did here is I take the 2 here and I look what is common. 3x between 9xy and 3x here. 3x is common, leaving me with 3y plus 1. That is 3x goes into 3x times 3y gives you that 9xy, and 3x times 1 give you 3x. And here a negative and a negative, so I take out a negative, and 4 goes into 12, and 4 goes into 4, and they have a z and a z here, so negative 4z is common. And in bracket you should have the same expression like this. Multiply back, you realize you get to those values. So just be careful when you take out a negative times a positive will give you a negative. So eventually everything that is outside the bracket, you put it in its own bracket, and everything, the common brackets, you only write them once. If you were to multiply out this expression, you'll get back to the original expression. Right, so we have got a is inversely proportional to the cube of b, so it's a bit variation. So when a is equal to 3, so inversely proportional, so you need to know the formula. All right, a is inversely proportional to, so you have got 1 over b cubed. So now we are given values of a as values of b, so we need to come up with what is known as the constant of variation. Right, so we use the letter K here to represent that constant, and I'm inserting now into the equation the value of A is 3 and my B is supposed to be 2. So I'm going to find what is that value of K. Well, 2 cubed is 8, and when you cross multiply 8 times 20 times 3 is 24. So now my constant of variation is 24, which means the general formula that I'm going to use with this problem connecting A and B is A is equal to 24 over B cubed. So they will sometimes now give you the value of B, find A, or they give you the value of A, then you find B. In part B, they say find the value of A, so it's straightforward. For 1 mark, you just substitute that B equals to 4 for B into that equation. And once you do that, you get 24 over 64, or anything that is equivalent to that. And you can also simplify it as 3 over 8. Anything equivalent to that is 100% correct. Question 7, you have a little bit of exponential equation, 7a here, so you're supposed to solve for x. Now what you do here is you are supposed to you realize you can't use indices here because you have what powers, but you can't use indices here because the base here is 5, the base is 8. There's no way for you to make the bases the same. So in that case, we are going to take the logs of both sides. So once you take log of 5 raised to x plus 1 and log of 8, and you use the power law, and I already went to that step, where you bring the x plus 1 down and simply divide log 8 by log 5. Now this is a calculator value, so I'll maybe advise you to not work it out first, but rather subtract, because you want to isolate the x. And once you are here now, because you maximize your chances of getting marks, you can punch it in onto your calculator and then you get whatever the answer would be. So that 1.292029674 and so on minus 1. So that gives you 0.292 and so on. But remember, we are giving our answer to 3 significant figures. So make sure that you also check the instructions and information to candidates in front of the question paper. Right, part B, you have got w to the 9th power must be divided by w to the 7th power. Now remember, when the bases are the same and you are dividing, you subtract the indices. So this is w squared. Question, we have Roman 2 here. So with this particular question, just be a little bit on the lookout that you have here 2 raised to the x plus 2 times 2 raised to the x minus 1 all over. Now you can't cancel, you have to simplify. Here you're multiplying same basis, so you are adding the indices. So I'm taking x plus 2 and I'm going to add it by x minus 1. Alright, the 2x minus 3 is all just going to remain like that because it's just 1 here, 2 raised to that power. Right, when you clean up the numerator, you're going to get x plus x gives you 2x, and 2 minus 1 gives you positive 1. Right, I'm just going to rewrite it in another form. From here, I'm rewriting in this form because if the bases are the same, then I'm subtracting the indices. That is why I had to put brackets here, because subtraction will involve every term in that particular expression. Now when you subtract, the 2x will disappear, and a negative becomes a positive. Okay, so if I remove the bracket, that is what I'm going to get, and I will eventually be left with 2 raised to the power 4. You can leave your answer as 2 to the 4th power or as 16, because that is the value for this particular answer. Part C, you're supposed to find the quotient and the remainder when you are dividing 2x cubed plus 3x squared minus 4x plus 5 with the quantity x plus 2. Now, you can use synthetic division or you can use long division. As long as you get to the answers, you can look at previous videos where I've done numerous questions on long division, or even synthetic, or what you can say short division. So first of all, x goes in 2x cubed, that leaves you 2x squared. Then you multiply 2x squared by each term, 2x squared times x, and that gives you 2x cubed, and 2x squared times 2, that gives you the 4x squared here. Draw your line. I like to put them in brackets because you're going to subtract. Now you're subtracting this. Now you have got 3 minus 4, that is negative. Now you realize I'm putting this in black because the reason why those ones are in black is because your side work, I'm actually saying 2x cubed and I'm dividing it by x. That is how I get the 2x squared that I have here on top. And then I take the minus x squared and I'll divide it by this x here. So I'm going to divide it in here. And I'm also going to divide it in here, and what I get I'm going to put all the way up there. So here I'm going to be left with for an answer of minus x, for example. So just to give you an idea what is happening and why I decided to play around with those colors there. Alright, so you do a side work, check out the work on long division or even short division in order for you to be able to master this question. Right, so let's continue then with the question. So now x into minus x squared leave you with x minus x, but before I like to bring down the minus 4x. Alright, minus x comes here from x divided into that, and now you go ahead and multiply. So I had to bring this down because if I multiply minus x times x, I'm going to get minus x squared, and if I multiply negative x times 2, I'm going to get minus 2x, and it should be subtracted from a like term. Right, brackets again, minus sign, draw your small line. This is going to cancel. Minus x squared minus negative x squared is the same as adding a negative, that gives you 0, and negative 4 minus negative 2, it's going to be negative 2x. You see I already have it again in that color, so x will be going into minus 2x. And when you use minus 2x, you divide minus 2x on the side, you say minus 2x, you divide it by x. Well, the x's therefore will cancel, leaving you with a final answer of nothing but negative 2. So before I do that, I like to bring the constant term down, and then I do that in order for me to get that answer. Now you are going to multiply that 2 by that negative 2 by everything that is on that side. So negative 2 times x is negative 2x, and negative 2 times positive 2 is the negative 4 that I have here. Okay, let me just remove these annotations. Right, so from there again I like to introduce my brackets, and also then I like to subtract, draw my line, okay, step by step so you don't make mistakes. When you subtract here you get 0, but then 5 minus negative 4 is the same as 5 plus 4, so the remainder therefore is 9. So now my quotient is 2x squared minus x minus 2, and my remainder is 9. If you are familiar with the remainder theorem, you can find the remainder and work your way backwards from there as well. But remember, use these things step by step. This is for revision purposes, and when you get stuck, you need to revise the topic and make sure that you get the method correct. Right, question 8, it deals with a little bit of transformation here, geometry. So we have got a big triangle here and a small one, and T is the image, is the original. Q here is T is the object, and this one here could be is an enlargement, as you can see, but let's focus on the object, the original, which is T. That's why it's shaded. So they say we're supposed to draw the image of triangle T after it has been translated by a vector negative 2, 4, and once you have done that, you label it P. Now remember, look at the scale so you can count correctly. The negative 2 is X direction, and if it's negative you have to go to the left. So I'm going to pick any point, go 2 places to the left, and then the Y direction is under. If it's a positive, it means you go up. If the Y was negative here, you go down. But in any case, your reflection, or not reflection, but the transformation that you get after translating that by that vector should be at this particular point. So you have got point negative 5, 1, negative 5, 2, negative 3, 2, and that is the image for 2 marks. Then they say draw the image of triangle T. Again, we focus on triangle T. It is the object, so you are supposed to reflect it. So here you have a line here. So remember, the reflection is going to be exactly, every point is exactly the same distance from the line of reflection. Alright, so for 2 points, your reflection should be somewhere around about there. Okay. Right, then there's a C part which I just moved a bit, do it just somewhere separately. You're supposed to describe the single transformation, only one transformation, that maps this T onto this Q. Now you can see that this is a smaller version, so this is a bigger version. So you can say enlargement, for writing enlargement, that's 1 mark. But now, there's also a scale factor, and scale factors can be calculated very easily. Well, you make sure you understand your scale. Every little square block here represents 1 unit, and so here. So this is remember to find the scale factor. It's the image divided by the object. So you take, like for example, you can count 1, 2, 3, 4, 5, 6, and you divide it by 2. Or you can even take 1, 2, 3. So you take horizontal distances by horizontal distance, or vertical distances by vertical distance. There's no point in finding this diagonal distance, because as a right angle triangle, that would involve you to use Pythagoras, and that is too much for this particular question. So there's one more thing that you need, and you need the center of enlargement. So I draw lines, join corresponding points, and you realize the center would be nowhere but at -6, -5. Right, question 9, expand and simplify, but be very careful here. Okay, you have got 3 terms. That's a term 3t, -5 is a term, this minus whole business here. So you use the concept of BOTMA, so you have to multiply out 2t minus 3 whole square. That means I write it like twice. Can you see? It's repeated multiplication. It's like that whole 2t minus 3 should be squared. So you can't go and subtract things from each other without doing multiplication. Right, so let me just bring in, my method would be wise to maybe finalize those brackets there, and multiply the first term by each term in the second bracket, and multiply the second term by each term in the second bracket. I hope you know how to do binomial expansion. Alright, so eventually I'll end up there. You see I haven't touched anything on the side. It's 4t squared minus 6t plus 9. But here I can still simplify. The minus 6t gives me either minus 12t. And now you must multiply now each term here by -3, okay, before you look for like terms. And what you do is -3 times 4t squared is -12t squared. A negative times a negative, remember, is positive. So 3 times 12 is 36t. 3 times 9 is 27. So negative times a positive. Right. So now we'll see if we have like terms. So let me just rewrite it properly. Minus 12t squared plus 36t plus 3t minus 27 minus 5. So I have the constants there. Minus t is going to remain, but 36t plus 3t gives me 39t. And then negative 27 minus 5 is negative 32. So 27 plus 5 with a negative sign. Question 10. Now, there's nothing to be afraid of here in question 10. So you have to find the value. So just use your calculator. You press cos of 123, which is negative 0.544. Please do not round this answer. Minus the sign of 223 degrees. Okay. You'll realize it's also because you're minusing, but it's going to be subtracting a negative. That's going to be the same as adding. Eventually, you should get to this answer. If you have a scientific calculator, though, you press cos 123 degrees minus sin of 223, you are going to find this particular answer, and then you give your answer to 3 decimal places. Make sure that when you are dealing with these questions in ordinary level, that your calculator is set on degree mode so that you don't get wrong answers. Right, here is imperative for us to solve the equation for sin x is equal to negative 2.5. We're going to look for values of x between 0 and 360 degrees, so it could be that there are more than one value. So first I divide by 4 because I want to simplify. I want to isolate that sine x. Right, now I have a ratio here, and sine x of negative 5 over 8. So I know that the sine ratio is negative, because sine positive in the first, it's positive. In the second, the cast diagram, sine is positive in the first quadrant and the second quadrant. So I'll go ahead and I'll scratch those ones out. So I'm looking for solutions for this equation will be in the third quadrant as well as in the fourth quadrant. So I put an x here, so we're going to find our angle x. But to find the angle x, I'm not going to use a negative on the calculator. Remember, when you press shift on the calculator, just find the positive angle. So you say inverse sine of 5 over 8. Not negative 5 over 8, because we're not dealing with negative angles here. So I'm looking for a reference angle. So my reference angle will be 38.6821. So I'm going to have it as 38.7. This is what I'm going to add to 180 degrees for one solution. And this is what I'm going to subtract from 360 degrees for the other solution. Because 180 plus 38.7 gives me 218.7. Well, if you punch that in your calculator, the sign of 218.7, it will give you roughly this negative ratio here. And the same applies 360 minus 38.7. Well, that gives you 21.3 rather. You can see that the answers are still within the domain of the solutions that we are looking for, between 0 and 360 degrees. Part C, also trigonometry. Now here you are supposed to find the area of this triangle. This is not a right angle triangle. Don't make any assumption. This is also not drawn to scale, so no measuring. So you need to use the area formula to calculate the area of a non-90 degree triangle. So you have got an angle that is flanked by two sides, and the formula is half times the sides that you have times the sine of that angle that is being flanked. That is very straightforward. So the area will be 149.448193 square centimeters. Go ahead and give it to three significant figures, which is about 149 square centimeters. Right, we have got algebraic fractions here. Now, very important, I have done quite a few videos on how to solve algebraic fractions, especially ones that are being subtracted and also ones that are being added to one another. Now, you have got 2x plus 5, you put them in brackets, and it's like sort of a cross multiplication, but not really. So you have got the 4x minus 3 here, and here you have got the 2x plus 5. It's very important that you keep them in brackets, and what you do is now you're going to multiply out the brackets. So 8 times 4x gives you 32x, 8 times negative 3 is negative 24. Careful with a negative times 2, negative 3 times 2x is negative 6x, but negative 3 times positive 5 gives you negative 15. Now, before you continue, you can clear out whatever you have there. Now, when you clear out, you see the negative 24, negative 15 will give you negative 39. So this answer here, as far as it is up to there, it's 100% correct. No need to continue like what some students will do. Okay, but if you were one of those people who continue, you factorize in the second instance, here you multiply out the denominator as it's equivalent, it will still be fine. But it's just unnecessary work. This answer ought to be okay. Question 12, you have got an inequality that needs to be solved. So you have got two inequality signs. So there are different ways that you can do this one. So what I did is I first added 2 because I want to isolate that p in the middle. So I add 2 on both sides of the inequality. So once I add 2 here to the negative 14, I add 2 here. I'm just left with 3p in the middle now. Negative 14 plus 2 is negative 12, and 10 plus 2 is 12. So now I need to get rid of that 3 there by dividing, because it's being multiplied by 3 by p, so I divide. So dividing 3 into negative 12 and also into 12 here, you get your answer will be p is a value that is between negative 4 and 4. Okay, make sure that you are writing the inequalities correctly and also that you don't make a mistake. Question 13. The ages of 5 children in a family are 13, 17, 9, 17, 5. So those are the ages of 5 people. So you've got 2 people in the family here with the same age group or ages. So they say find the mode. The mode is the one that appears the most. Very straightforward. You can see the mode here is 17. The median is the one in the middle, so you need to arrange the data. So once you arrange the data, you will find that 13 is in the middle, is the median. The range means you take the highest, subtract from the lowest, and the highest subtract from the lowest. 17 is the highest here, and the lowest is 5. Okay, and 17 minus 5 gives you 12. So again, if you calculate the median, you need to arrange the data. So I've got 5 here, then followed by 9 here, then followed by 13, if I'm not mistaken, and then you have 2 17s there. Okay, so you can clearly see that the one that is in the middle, is 13. So it is the median, middlemost value. Very straightforward question. Find the number of sides of a regular polygon with an exterior angle of 24 degrees Celsius. Now, what you need to remember is that all exterior angles of all the polygons, no matter what type of polygons they are, no matter if they're regular or irregular, all exterior angles will always add up to 360. So you can find an interior angle simply by dividing 360 by 24 in this case, and it's a 15-sided polygon. Part B, you're supposed to find the value of A and B. Now I am bringing in, obviously you know that here you have got co-interior angles. And co-interior angles, they add up to 180 degrees. They are supplementary. So this little angle here is 52. But then you can also see that this is 128 here, because 52 plus 120 will give you that straight angle. So therefore A is 128, but B is vertically opposite to 52, so B is also 52 degrees. So your two answers, whatever method you use, is A is 128 and B is 52 degrees respectively. Right here we have got an isosceles triangle. It's very easy for you to identify C should equal to B, 54 degrees, because base angles here of an isosceles triangle, base does not beat bottom. They are simply the angles that you find after you have your two identical sides. So that C should equal to this 54. Therefore C is 54 degrees. Right, so you've got question 15 here. So we are supposed to work out the gradient of this line. This line is the line y equals to g of x. They don't want to tell you what the line is. Perhaps they will ask you to write the equation of the line. So the equation is y is equal to a function of x. So this is just the same as whatever that equation g will be. It's going to be something that we calculate. But first we can calculate the gradient. So I have highlighted 2 points here. You can see I have 2 points here. I have the point -2, 3, and also the point 2, -3. Well, since I have 2 points given, I can calculate the gradient. Correct? Gradient is delta y over delta x. So I take the one y value, subtract another y value, as I did here, and then take the corresponding x value, subtract the other x value. Well, that gives you the gradient as -1.5. However, you can also simply calculate the gradient. So one of the things when calculating or using the grid is look at the slope of this line. Right, so this line is going sort of in a downhill direction, so the gradient will be negative, number one. So once you are using that logic, then you will be saying minus for the gradient. And gradient is the y distance. In this case, you can take this 3 divided by that. And 3 divided by 2 would be 1.5. Right, any case, they are saying they're giving us another function. So we have got function f now. So we have the straight line. We know what our straight line is. No problem. Okay, so we need to complete the table. I've done quite a lot of questions on functions, so I will advise you to go back, have a look at them as well. Right, so you complete the table. So everywhere of an x, you can substitute with -1 for you to get a value. You should get 0 here. Here, everywhere you have an x, you substitute 2 in here, put brackets, very important. You should get -3 as an output for y. And everywhere where you have x, you substitute with 4. So 4 squared minus 2 times 4 minus 3, you should get 5. Now I have got all the points that I got. My table is complete, and now I can plot these points on the grid. So once I plot them on the grid, I expect those points to be there. So obviously the point 2, -3 is already here. So these are my points, and then I'm going to draw the graph. And so we draw the graph. It's a parabola, and as you can see, it is a parabola with a minimum turning point here. Okay. Right, so you can also go ahead and label your parabola. So we have got more questions that we need to answer from our graphs here. So we have got 2 graphs. We have got G and we have got F. So write down the coordinates of the turning point of the graph. Well, it's very easy. You see I indicate with the arrow. That's where it turns. The coordinate turning point will be 1, -4. First x, then y value. And we are supposed to determine graphically the solutions to f of x is equal to 0. That means this parabola where it's 0, that means where y is equal to 0 and y is equal to 0, where the graph cuts the x-axis. And those are those points. One is -1 and the other one is 3, no matter which one you give first. Those are the values of x when the function here, x squared minus 2x minus 3, is equal to 0. Now, once you have f of x equals to g of x, it just means write down the values of x where the two functions are intersecting. That means where the straight line and the curve here intersect. Well, here it's very straightforward. You can see x will be 2, and here x will be negative 1.5. Thereabout, and these are the solutions that we are looking for. Remember, your graph should be smooth. When you plot and draw this graph, you should use a free hand. Okay. Right, question 16. Now, well, question 16, I have done a separate video on question 16. It deals with construction, and I've tried to show you in that video how you are going to attempt to solve this question. So on the next slide, I am showing you, under this slide, I'm showing you the link to that particular video, or you go to my channel, you should find that particular video that I have done on this particular question. Question 17 deals with coordinate geometry. So you have got a quadrilateral ABCD. It has got vertices A, B, C, but they don't give you the coordinates for point D. You're supposed to find, first of all, the midpoint of line AB. Now, it's very important and very straightforward. To find the midpoint, you average out the x coordinates and also the y coordinates. So you take 2 plus negative 6, its average, and then you take 3 plus 9, its average, and you realize that x should be negative 2 and y will be 6. Finding the modulus of the line, the modulus of the line, or the magnitude of the line, the length of line AB, you use Pythagoras. But then when you use Pythagoras, you have to find the distances between your x values. For example, you have got 2 minus negative 6. I'm taking the difference between x values here, square that. Difference between y values, square that. It simply doesn't matter which point you start first. You can also have negative 6 minus 2 and 9 minus 3 all squared. Here you are going to eventually arrive at the same answer. So everything that you square, no matter it's negative or positive, always give you positive answer. So negative 6 squared is going to be 36. 8 squared is 64. Clean that up, gives you 100. The square root of 100 is 10 units. So whatever that length is in whatever units, centimeters or whatever, it will be 10. Question 18, they are saying line AB, which we now know what degree, line AB is parallel to line CD. We, from our previous slide, know that line AB, parallel lines, their gradients are equal. Line AB's gradient, if we calculate the gradient of line AB, we know that the gradient will be negative 3 over 4. So 9 minus 3 over negative 6 minus 2, that is for me to find the gradient of line AB. And whatever the gradient of line AB is, it's going to be the gradient of line CD also. So my equation now for line CD will be y equals negative 3 over 4x plus c. So what you need to do is you go back to the paper and then you find the coordinate point of C, because we're now looking for the y-intercept. We need to find this y-intercept. So go to point C, the point that we are not given point D if you look at the question, but we have got the coordinates point C. So you substitute those coordinates for x here and for y in order for you to calculate the value of C, which is known as the y-intercept. Right, once you clean it up, you're going to realize that C is nothing but 5 3/4 or 5.75. So now my equation is complete. It's y equals to minus 3 over 4x plus 5 3/4. Now it's totally up to you how you want to leave your answer, as decimals or everything all over 4 is totally up to you. Okay, so you can definitely decide. Part D, they are saying the equation of line BD, and they are giving us line BD. We now know from our previous answer what is the equation of line CD. So we now are told they intersect, therefore when they intersect, we're going to let them be equal, and we multiply throughout to solve the equation by multiplying throughout by 4. And you get 9 minus 4 times, or 4 times minus 2x is minus 8x, and 4 times negative 3 is negative 12, you got it correctly. From here it becomes a linear equation, collect like terms, and then you start solving for x, and x will be negative 7. Now, you take this answer for x, you can now substitute in any one of the equations. Preferably, I will substitute the equation they gave us here. All right, so I'm going to substitute in equation BD, and that is going to be y equals negative 2x minus 3, and x is negative 7. Clean this up, you will realize that y is 7. So the is 11. So the coordinates, therefore, is of D would be negative 7, 11. So, question 18. There are 12 fruits in a box, and 6 are apples, A for apples, 4 are oranges, O for oranges, and 2 are bananas. So, what is the probability that a fruit taken at random is a banana? So, it's very straightforward, 2 out of 12. Now, you can definitely go ahead and you can simplify if you want to 1 over 6, but the answer should be fine as 2 over 12. Right, then 2 fruits are picked at random, so you have to complete the tree diagram to show the probability. Now remember, between the branches, like for here, the first fruit, 6 over 12 plus 4 over 12 plus something over 12 should give me, you are correct, should give me 1. So when I go down here on the branches, I should always have a 1. So it's very straightforward and easy to find those missing values. So 6 over 12 plus 4 over 12 gives you 10 over 12, so 2 over 12 is going to be left. So whatever you do, as long as you add these 3 branches here, you should have 1 as an answer. So second fruit, 5 over 11, 4 over 11, and 2 over 11. Now here the 5 comes about, you are taking an apple. So when you take an apple, now the 4 oranges will still remain, and the 2 bananas will still remain. Here, you are taking now an orange, that's why it's become 3. So the 6 apples will still be there as they were originally, and the 2 bananas will still be there as they were originally. Once you take 1 banana from here, then the 4 bananas will still remain, and the 4 oranges will still remain, and the 6 apples will still remain. Anyway, you should know that when you add along here, you should get to 1. So this is how you complete this tree diagram. Right, so I brought it back here. So we're going to use it to find some solutions to some questions. So they say, what is the probability that you find when you pick at random, you will have both of them will be oranges? So you go to orange and orange. So you go oranges 4 over 12. Now when you go along the branches like this, you multiply. So both of them to be oranges 4 over 12 times 3 over 11. And whatever that answer is, you can simplify it, but it's 12 over 132. What is the probability that you pick fruits at random between an apple and an orange? So apple and an orange, there is a combination here that you have an apple and an orange. So it's either you take an apple and orange, which is 6 over 12, times 4 over 11. So when I go along, but now I'm adding or either an orange, which is 4 over 12, times an apple, which is 6 over 11. You simply find the answer to that, which is 48 over 132, or 4 over 11 when you simplify it. This question here, at least one is a banana. There are many ways that you can answer this question. Sometimes it will take you a little bit longer, but it is not as difficult as it is. So what I did is I color-coded my apples and apples. So what I'm doing here is I'm considering what possibilities there can be. I can't have an apple and an apple. Because when you say at least a banana, that means there should be a combination of maybe an apple and a banana, or an orange and a banana, or banana and a banana. But here you have an apple and apple. So if I take away the apple and apple, so I take 1, everything, minus an apple and apple. Then another combination I have an apple and an orange. Also there I can't have a banana there. So I say 6 over 12 times 5 over 11. Also 6 over 12 times 4 over 11. That is what I also can't have, because you can't find bananas there. You also can't find a banana when you have orange and orange. So 4 over 12 times 3 over 11. That is an orange and orange. Also an orange and an apple. So 4 over 12 times 6 over 11. So if I multiply all of this and add them together and I subtract them from 1, that is 1 minus 15 over 22. So the correct answer should be 7 over 22. Now, the diagram as I drew it here can also be helpful when you consider taking away the colors that I have put. So obviously if you want, you can now take the 6 over 12 You can say apple plus a banana. That's apple times a banana plus orange times a banana plus banana times an apple, banana times an orange, banana times a banana. So I have done it here under the possibilities that you have. AB means you multiply apple times the banana for that first branch there, and so on and so on. You will also arrive at the same answer. Takes you longer, but you should be getting 7/22, which is the correct answer. Right, question 19. The table shows the time in minutes that 160 learners spend on studying each day. Right, they are saying we're supposed to complete the accumulator frequency table. Let me just explain the first table to you. It took 26 learners between 0 and 20 minutes. So 26 learners, they studied 1 minute, or or even no minute at all, so nobody studied, but 26 of them fell in that class interval. Then the learners who spent between 20 minutes and 40 minutes, less than 40 minutes, were 40, and learners who spent 40 to 60 minutes were 50, and so on. Now, something else, as it accumulates, we add them. So, for example, if I want to say how many learners actually spend less than 40 minutes, it has to be the 26 learners here plus the 40 learners there. Those learners are the learners who spend less than 40 minutes. How many learners, because it accumulates, so you add it as it goes. How many learners spend less than 60 minutes? The total number of learners who spend less than 60 is 26 plus 40, which we know is 66, but plus this 50 as well. So all 116 of them, all these three, spend less than 60 minutes. Some of them have 5 minutes, they still fall within the given frequency. How many learners have spent less than 80? Again, you add 26 plus 40 plus 50 plus that 30, or 116 plus 30. And you should end up with 160, which is the given total of the data that you were given. 160 learners. You should end up with 160 learners. If your table is correct, you can now definitely go and plot this on a graph. You get the scale, and you will realize you will have accumulated frequency diagram. Bring the table back here, and I also have my graph here, and you probably now follow the correct scales that you were supposed to use in order for you to complete. So I'm going to go when 0, obviously learners with less than 20 were 26, but 0 is also included, so 0 learners, no time. Okay, so I can plot for 0, and I can plot each one. Less than 40, 66. Less than 60, 116, and so on. You should end all the way up to 160. So once you plot, then you draw the curve with your free hand. You should get this ogive that we have here, or this cumulative frequency diagram. It makes this like a longitudinal S. That is the type of shape that it takes. So from here, we are going to read some values, like we're going to find the upper quartile, which is 75% of the data, and the lower quartile, which is 25% or a quarter of the data. All right. And sometimes they'll ask you questions like the interquartile medium or the interquartile range. Okay. So we're going to use the diagram to answer those questions like that. Let me go back to part C and start answering. The question says, use the frequency. Now you use your graph. And you are going to use your graph to find the lower quartile. Remember I said lower quartile is 25% of the data. 25% of 160 is 40. So I'm going to go to 40 learners, and I'm going to read down because I want to find the time. When I read down, I'll realize that I get 28 minutes. So you have to use your graph to find that. Upper quartile, remember I said it's 75% of the data. So 75% of the data is 75, 160 is 120. So I go to 120 and I read down what is my total number of student time, and I'll realize it's 62. So it's very important that you also know what does one little square represent here. So 20 divided by 10, so one square is like 2 minutes. And here 20 divided by 10, one little square here represents 2 students. Right, so the interquartile range, you find that by calculating obviously now my upper quartile is 62 minutes. So the interquartile, you take your 62 minutes, you minus with your 28, and you get the correct answer of 34 minutes. So the majority of the learners, the majority of them, okay, they spend about 34 minutes. That's what you have here between 62 and 28, studying for this whatever examination, whatever it is they are studying. Right, then there's a part C to the question, which is the last part of the last question. It says, use your diagram to find the number of learners who studied for over half an hour. So let me go to where half an hour is. Half an hour is somewhere here. So up to here, 44 learners and less have spent less than 30 minutes. All right. So to find the number of learners, it had 160 up there. The total number of learners minus the 44 will give you the total number of learners who spend more than half an hour studying, and you realize it's 116 of them. Okay, so I hope that this video was very helpful, and you can always pause and you can always rewind and go back and check, but I suggest that you do this while you are working out the questions. First attempt to work them out on your own. Good luck with your examinations and with your studies.